We finally have a price for the Steam machine. Not this one here because this is just a 3D print of what it's going to look like, but we know what it's going to cost, so I finally want to take this opportunity to build my own around that same price and hope for some better performance. So let's dive into the build and we'll go over parts, everything like that. We'll do a side-by-side comparison with our model here, and then we will look into some benchmarking numbers compared to what we've seen from other creators so far. I suspect a lot of people are just going to skip ahead to the price and the performance of this machine, so I'm going to go ahead and just list that out now. The parts list, we have a 7500 X3D combo. Went ahead and sold the motherboard that came with that for $80 because it was an MATX, so we want something a little bit smaller than that. Picked up this ASRock B850i Lightning for $160, so our difference there ended up being about $80, bringing our combo price up to $380. Picked up a 9060 XT 16 gigabyte. Had to go with a different model actually and use one that was a smaller form factor for this case I picked. The Patriot P400 Lite 2 terabyte. It's a Gen 4 2 terabyte SSD. Cooler Master V850 small form factor power supply. And then the Thermalright AX-P90 X36. It's a small form factor CPU cooler. And then we are going with a custom printed case to kind of match the Steam machine look, and we'll go over that here in a little bit. All right, a quick snippet of performance, and we'll go over specific settings per game later on in the video, but this is just a quick shot for anyone that wants to see it. All these games were played at 4K. 007 First Light averaged 79 FPS. Crimson Desert 64 FPS. Cyberpunk 2077 64 FPS. Forza Horizon 6 68 FPS. Horizon Forbidden West 69 FPS. And Pragmata was 64 FPS. These are the goals of our Steam machine. So first we want it to be current gen hardware to leave room for upgradability. Want it to be a small form factor build to kind of give it that console feel. And then we are going for living room convenience, which means no keyboard and mouse would be needed. And we want to have some sort of TV control like a console would using CEC. And then we want the full freedom of PC gaming, whether that's emulation, using multiple launchers, or just browsing the internet. All right, so to replicate this, we're going to obviously go with a lot of small form factor parts. So there's a lot of good small form factor cases out there, like the Fractal Terra, things like that. So thought about maybe picking a popular one of those, but I really wanted to go for a replicated design of the Steam machine, something that looked very similar, and there's really nothing out there like that. So I went into the 3D print world. I do have a 3D printer, looked at Maker World. There was a couple nice designs on there that printed out some tests of, and it just wasn't quite what I was looking for. So I almost dove in, and I do like the Terra case a lot, so I almost did that. But then I came across a video by Zach Builds right here on YouTube where he designed his own Steam machine case, and he had the files available to purchase from his Etsy. So I went ahead and did that. Huge shout out to him. If you want to go check out those files, they'll be in the description below, or you can scan the QR code here on the screen. Zach came up with a great design. I'm not going to go into the full iteration of it, but you can go check out his video to see all the different iterations he went through, the tweaks he made throughout the process, and the whole design phase. So go check that out if you want to see it, and we will get into the rest of our build. In this 7500 X3D bundle, the CPU comes pre-installed, so we had to uninstall it. I had an extra socket cover that I put on here to get this motherboard sold. All right, so our build is complete. Our little side-by-side here, you can see they're actually close to about the same height, but as far as depth goes, we have quite a bit longer depth there, deeper depth, I should say. And then, yeah, this is definitely a smaller form factor. We have a lot more vent holes here on our version with the Steam Machine only having this one on the back. So actually a pretty impressive design on their part, and interested to see how the thermals perform on this machine. But we have our design built, so we'll go ahead and get our SteamOS running on there and then start testing out some games. So here's actually a beta version of SteamOS, but this week with the announcements and pre-orders of the Steam Machine, Valve actually released an official version of this for PCs. So I would check that out, install that, and it should run pretty flawlessly. This beta version, if you're not familiar with Steam, this is your main interface with all your games up top. You got menus you can access. It just gives you a really simple interface. You can go into your library. So this gives you games that are verified to run well on SteamOS on the Steam Deck. On something like this, you shouldn't have really any issues running any game since you're running on actual PC hardware. But here you have all your games. You can go to all games in that section, whether they are optimized or not. This just shows your whole library. Go to installed to see what you have downloaded, and then non-Steam games. This is where you can add emulators, other launchers, things like that. Here I just have Google Chrome, and OpenRGB is what I used to control that front light bar. So some things like that you'll have to boot into the desktop mode, which is just running Linux, and then you'll install things like OpenRGB and then add them to your library so you can just access them without having to go into desktop mode every time. So one of the big features that we've seen from Steam on the Steam Machine is the customizable front panel. So we could still, in this design, pull this right off thanks to Zach's cool design here. I don't think I could get that magnet out when I was gluing it, so that one popped out. I wanted to do something kind of unique, so I dove into trying to 3D print something that was like a green translucent, being a 90s kid with the old Macs with the translucent backs, the Game Boys, Nintendos. I think I had a jungle green N64 myself, so that's kind of what I was going for here. But after many iterations and failed attempts on the 3D printer, doing a lot of little test prints, trying to find that perfect glass-looking, see-through plastic look. We came pretty close, and there was an original thought of maybe doing the whole thing this color to see a see-through green case. That would be really cool. But this piece alone ended up taking 48 hours, and it still was not quite perfect. So probably not a practical idea, but it does have a cool look on there still. Maybe putting some RGB RAM or something inside of here, help light it up a little bit, would help with that. But it was worth a shot, and we'll maybe keep working on that. But another option I came across was this green filament I had, which is actually a color changing filament, so it'll change colors when heat is added to it. So obviously gaming PCs, they produce a lot of heat. So as you game on this, you can kind of get the design changing and getting a new color from it, which is pretty cool. So with our complete build here, just jumping into some initial testing, we're definitely seeing some higher temperatures on CPU. Tried double checking thermal paste, things like that, but I think there is some exhaust going on here, but it's all passive. So I wanted to bring in a little bit of extra help with exhausting there. So the first thing we did, which I've seen done in a lot of small form factor builds, kind of a cheat code, is to flip our power supply out. So instead of pulling air in from the top and exhausting out the back, I flipped it so it's now pulling air from the inside of the case and then pushing it out the back. So that's going to help kind of exhaust some of that hot air. You are then pushing hot air through your power supply, so that's not an ideal situation, but it is something I played around with here. That alone didn't help drop temps a whole lot, but then I decided to modify the design on our front panel here. So instead of being solid on the sides here, and with this X pattern, I kind of got rid of most of that pattern, and left it open on the sides so we can install a front fan here, and it'll exhaust out both sides of here. And that actually, we saw pretty good temperature increases with that, with our color changing. Obviously not as clean of a look on the sides here now, but we are getting that extra airflow coming out when that fan is installed. To make this a console-like experience in a living room, when we turn on our controller to then turn on our system, we want to see our TV turn on with that. So you can see in the current setup, just plugged into HDMI on our graphics card, it is not doing that for us. I went ahead and picked up a DisplayPort to HDMI converter. This is from Ugreen. This is the 8K 60 hertz, and it'll do 4K at a 240 hertz version of this. I'll have a link down below in the description, but running this directly to DisplayPort actually ended up solving this issue for us. So as you can see here, all we need to do now is go grab our controller, go have a seat on the couch, turn it on, kicks our Steam machine on, which will then eventually turn on our TV. And it detects what I named it in SteamOS, which is just Steam Machine. This is on an LG C1 OLED, so you might have a different experience with this, but this is what worked for me. Just make sure in your SteamOS and in your TV settings you have CEC enabled on both. Play a game, all you have to do is turn on your console. It'll detect that as the new active signal, and it'll go ahead and automatically switch over as well. I did not have any luck getting it to turn off whenever I put the Steam machine to sleep, but I tested this on my Nintendo Switch and on my PS5, and neither of them turned off the TV either, so I think it could just be an issue with my settings on my TV or something like that, but it's at least consistent with the other consoles in the room. And now we'll finish it out with those game benchmarks. If you look in the lower right, you can see the settings that were used and what the average FPS was for each game.
That's close! It's him! Carefully! I'm jammed! I'm bleeding!
Show some respect.
Alright, that's going to do it for this one. Thank you for watching. Hope you enjoyed what you saw. And if you did, give us a like, hit that sub button so you can see more projects like this in the future. We will see you in the next one.